on Spring for Rabbit, Super Streams, and SQL filters. Now, I'm going to get into what I mean by all of this stuff, but I want to start out with an introduction. My name is Gregory Green. It is an honor and a privilege to be with you today. When I found out my talk was accepted, I was so humbled, and I'm just so excited. At my position as a solution architect on the Tanzu division of VMware, which is part of Broadcom, I have the privilege of advocating for all of our data products, and RabbitMQ is one of our data products, but I also have lots of experience with Spring, so I love telling the story of how our data products can help with Spring applications, and that's pretty much our agenda for today. I like to start out by, when I'm talking about a technology, explaining what problem or what challenge is it trying to solve, and Rabbit is all about application messaging. So if you have an application, suppose you have a publisher application and a consumer application, and the publisher needs to send some information to the consumer like, hey, the RabbitMQ session has started. And what if the consumer application is not available? Maybe it's distracted, maybe it's looking at its phone and it missed the message, right? Or it's just not running. Well, what if the publisher needs to send some important information, like God forbid, an emergency happens, like a fire or something breaks out. So it needs to send that emergency message to run. Now, if the publisher app was not available, the publisher can be nice and it can try to resend those messages and to retry now. And there are some frameworks in Spring that make retrying easier, but you can't just keep retrying forever because you're an application. And you have other information that you need to share. And maybe there's a spike in messages, right, that needs to be sent. Maybe hundreds of thousands or millions of messages that needs to be sent, and this publisher application or this consumer application is not running. And what if you have another instance of the consumer application that comes later, and it needs to get those messages, especially the emergency message that it needs to run, right? So I always advocate, instead of putting all of these application messages and concerns into your applications, you should delegate it to a messaging system like RabbitMQ, and I'm going to get into RabbitMQ Streams, but I want to start with Rabbit. So Rabbit, as I mentioned, it's a messaging system. I know we're not supposed to have favorites, but it is my favorite messaging system. I also call it a message broker. It's been providing reliable delivery for a long time, right, since 2007. Now, with Rabbit, you have these traditional data types, or this traditional topology, right? So when you publish messages, you publish to an exchange, right? In other systems, you might call it a topic, right? And then ultimately, those messages are routed to a queue. And there'll be some routing rules on which messages are routed to which queues. Now, queues are sort of like the inbox for the applications. So when you send that message to a queue, it's first in, first out. And when the consumer consumes that messages, and it says, hey, Rabbit, thank you for the message. I've successfully processed it. Those messages are removed or it's destroyed. Now, but Streams is a little bit different, right? Now, it's a newer technology, but it's not new, right? It was available since RabbitMQ version 3.9. At the time of today's talk, the current version of Rabbit is 4.2, right? So again, it's been about 5 years or so now. With a stream, when you publish a message, it's in a pin-only log, right? So it's always publishing to the end, and that's how it maintains the first in, first out ordering, right? But it supports higher throughput, and when the consumer consumes those messages from the stream, it's not a destructive consumption. So the consumer can always reread those messages. So in that case, you could kind of use Rabbit as another source of truth or as a data store. So again, if you have on the same broker or the same messaging system, you can now add to your exchanges and your queues by introducing a stream. Now, for Spring applications, it's super easy to get started and to incorporate streams into your apps. Just head over to start.spring.io and add these particular projects. In particular, the project Spring for RabbitMQ Streams. That's going to bring in the lower level APIs to work with Rabbit Streams. But by show of hands, how many of you are already using Rabbit for your Spring applications? Okay, great. It looks like a lot of you are, right? So there is a project Spring for Rabbit, and that includes, it's also known as Spring AMQP. AMQP is a protocol. It's called the Advanced Message Queuing Protocol. It's the default protocol for RabbitMQ. And there's different versions of that protocol. There's the 1.09, and there's also the 1.0 spec of that. So Spring for RabbitMQ, it basically provides some higher level abstractions, so you don't need to use the lower level APIs. But there's two other projects that I really love, and it kind of hides the fact that you're even using a message broker. Like, for example, Spring Cloud Functions. How many of you are familiar with Spring Cloud Functions? Okay, a couple of you are. So with Spring Cloud Functions, you're basically just implementing a Java interface, right? So it's a function interface. So at the end of the day, all you are concerned about is receiving a message or receiving an object and returning an object, or doing any combination of receiving and returning, right? And the fact that you're actually talking to a messaging system is totally abstracted to you. So basically, when you have this function, then you'll have a binding, which is included in this Spring Cloud Streams project, right? So the Spring Cloud Streams will take your functions or your interfaces, and they'll allow you to talk to a messaging system like RabbitMQ. So it's all super easy, and I'm going to show you in a demo. But how does Streams help your Spring applications, right? So I'm going to start with replay, right? So again, when that consumer application was distracted, it didn't get the message, right? Rabbit keeps track of all of the messages that a particular consumer has processed, right? So at the end of the day, there's something called an offset. Offset is just a number. You could think of it as an index to an array, where the array is basically this stream, right? So each consumer will have a name. It will register its name with Rabbit. So Rabbit will say, hey, for this stream, maybe that particular consumer didn't process any messages, so it starts at 0. But if there were 2 messages in the stream, and the consumer processed those 2 messages, then again, when that consumer starts up again, Rabbit will say, hey, I don't have any new messages for you. But the good thing with replay, you can always, as an application, you could tell Rabbit which offset you want to start from. So if you want to start from the first record or a specific offset, you could absolutely do that. Now, I'm going to show you how you would do that in some code. So I have RabbitMQ running on my machine. I'm going to go ahead and log in. So when you log, most of you who know have used Rabbit, default password, guess. So I have one broker running on my laptop. You see everything's green, so it's all healthy. I have these default exchanges, right? So these are just out-of-the-box exchanges that you can use in your applications. But if I click on queues and streams, I don't have any queues and I don't have any streams. So I'm going to start out by starting my consumer application. So I have these two applications inside of my repository. I downloaded them from start.spring.io. And if I look at my consumer app, again, I'm using Gradle. Again, if you're using Maven, you can absolutely use that. But this was all created for me from start.spring.io. And here it included the Spring for RabbitMQ project, and also the Spring AMQP project, and some other projects that or dependencies that I'm using in this application. And also, it generated this consumer app, so you already know this. This is going to bootstrap Spring for me. So if I want to put in my consumer logic, I'm going to go ahead and to create a consumer. I'm going to have a config object, and I'm going to add some annotations, and I'll bring in some Lombok. And all of my logic in this case, I'm going to put it into this consumer. So again, this consumer is just part of Java util functions consumer interface, right? If I look at the implementation of this, again, this is just plain old Java where it has an accept method. And this accept method is basically the message or the payload. So if I wanted to receive binary, then I can say my input to my accept method is an array of bytes, or if I wanted a string, or I can use whatever object that I need, my domain object. So in this case, I have this domain object, which is a Java record. And it has these fields like the event, the session, and the year, right? So at the end of the day, what's going to happen is when there is a message on the stream, Rabbit is going to push that message to my Spring application, and the Spring project is going to convert this to this payload for me, right? Now you notice that I don't have any reference to Rabbit inside of my import statements, right? So because this is basically this is what Spring Cloud Functions does for me. I don't need to put in the lower level references, but I need to tell it something. So I'll put all of the configuration details actually in my application properties. So in this case, I'm specifying my application name and the port of 0. So it's going to generate a port for me. And then here, again, this is Spring Cloud Functions. And I'm specifying the bean name that I'm exposing as a function. If I go back here, if I kind of look at these side by side, and I'll bring this a little bit over to the side. So this is my bean, and this is my bean name. And this matches that function definition. So again, it's just looking for that bean, and it's going to expose it. And it's going to create some bindings. So the binding basically says for that bean, I'll have an alias, which is called input. Let me make this bigger. Let me close this. I have this alias called input. And I have, for this alias input, I have two things. I have a group and I have a destination. The combination of the group and the destination, that's going to create a stream within RabbitMQ. So let me go ahead and I'll start this application. I'll actually start this instance of it in debug mode. So when I start it up, this is going to establish a connection to RabbitMQ. We'll make this bigger. And if I go ahead and if I look at the management console, so now we have one stream that was created. And I don't have any messages in this stream. So let's go ahead and let's populate some messages. So I'll jump over to, close out all of this, and I'll jump over to my consumer app, my producer application, I should say. So just like before, I have my Gradle, and I have my dependencies. I have Spring for RabbitMQ. I have the Spring Cloud Streams dependencies, Spring AMQP. And I have my app, my publisher app that's going to bootstrap Spring for me. So I'm going to put my publisher logic in, just like before, into a configuration object. And I'll add in a configuration. I'll add in some Lombok again. Now, the first thing I'm going to do is I'm going to add in a Rabbit Streams template. Now, this is part of Spring AMQP. So again, this is going to hide the low-level details to send data to Rabbit, but it's actually going to use Streams, the Streams protocol. Make this bigger. And Rabbit, when you send messages to Rabbit, the actual message is basically just a black box, right? It's just binary, right? So I can define how I want to serialize those particular messages. In this case, I'm using JSON. And I'm going to also include my application runner. So my application runner, when it starts up, it's going to use the template. It's going to send this message, welcome to the RabbitMQ session. So when we go ahead and start this publisher application, all right, so that sent a message, and if I go back to my consumer, now we're seeing we've consumed that message. Now, if you look, the session in the year is not populated, right? So let's go ahead and I'll go ahead and I'll populate the session in the year. So we'll say the session is Rabbit, and the year is this year. And instead of welcome to the welcome message, let's go ahead and I'll send this emergency message. So I'll say, emergency, run, fire, and then I'll be nice, please. Okay. So when I restart this, and let's jump over to the consumer application. All right. So I got these two messages. If I go back to Rabbit, I'll see that I have the messages populated into the stream. So good, everything's good. But now, let's suppose, what if I start up a new instance of the consumer app, right? So if I start up a new instance of the consumer app, so I have this instance is running, I'm starting up a new instance. What happens? I don't have any messages, right? Because, again, Rabbit tracked for this instance of the app, which is using the same name, you've already processed the messages. So I don't have any new messages for you. But what I could do is, like I said earlier, I can always specify the offset. So I'm going to go back to my configurations, configure, and I'll specify an offset. So in this case, ultimately, I'm specifying this offset specification, right? And I'm saying start from the first, or start from the beginning. If I look at the definition of the specification, there's different offsets that you can set. You can say no offset, or the first, or the last, or the next, or I can specify a number. Or I can specify a particular point in time so you can allow you to time travel. So a lot of flexibility here. So again, since I specified it, I'm starting at the first or the beginning. When I restart this particular instance of the application, let's see what happens. All right. So I got my two apps, right? So I was able to replay those messages from the stream, right? And any instance of my app, now that I start up, it's just going to basically use the offset, right? So when I start this instance of the app, again, I'm replaying those two messages, all right? Makes sense. So let's move forward in the talk. So now you can, in addition to replaying, Streams also helps your apps by providing higher throughput. Now, what do I mean by high throughput? For years, if you had maybe hundreds of thousands of messages per second, maybe 1 million or millions of messages per second, typically in the past, you wouldn't consider using RabbitMQ. You might use one of the competing technologies. But the Rabbit product team, which I am a huge fan of, they did an outstanding job of developing not only this new data type, but also the protocol that's used to send it. And it's extremely optimized. So now you get really high throughput. So I'm going to show you what I mean by high throughput. I'm actually going to hop over to another instance of an application. And I'm going to walk through some code. First, I'm going to start this. I'm going to start this instance, and then I'll walk through the code. So ultimately, what this is trying to do is this is trying to create 17 million messages, right? And just like before, I'm using the template, and I'm customizing the template. So there's something called a batch size, right? So by default, when I send a message to a stream, the Rabbit client is going to use a default batch size, which is 100. So it's going to send 100 messages at a time. So I'm basically improving or increasing that number. But also there's something called sub-batching, right? So you can think about it not only sending an array, but an array of an array. And when you have sub-batches, that's when you can also compress the messages, right? So again, I'm just tuning these to send them as fast as possible. I'm sending this message. In this message, the payload is basically this payload. And I have this application runner, and this application runner is trying to calculate how fast I'm actually sending those messages. So if I look at the output, this basically sent over 1.5 million messages per second. So let's see if all of the messages actually got into RabbitMQ. So again, I got all of the 17 million messages, right? They were published at 1.5 million messages per second. I don't know if that impresses you, but that's pretty fast, right? And this is just my local laptop, right? So again, if you had a more powerful machine, again, you can get more and more throughput from this, right? So, but also now building on the fact that on my single laptop, I can get over 1 million messages per second, right? Rabbit also supports a way for you to scale out streams. And it uses something called super streams, right? So super streams is basically a logical collection of streams. When you create a super stream, you specify a couple of things. You specify a partitioning count or how many application instances you have. And also, it's going to use something called a partitioning strategy so that messages that have something called a routing key. You can think of a routing key as some sort of like primary key for the messages. So every message that has the same primary key is basically going to be routed to the same stream. So in this case, I have a stream of 2 partitions, which are super stream of 2 partitions, and this equates to 2 streams. And when I send a message, every message with the same routing key is routed to the same stream. And so when I have my 2 instances of my application, each one of those applications will basically own one of those streams. Again, and then the streams are keeping the order. So that's how you maintain the first in, first out for the message processing. Let me show you what all of that means by an example. So I head back over to my application. I'll stop this publisher application, and I'll head back over to the other instance of my project. All right, so I'm already in my consumer. The only thing I'm going to basically change with my consumer is I'm just going to delete this offset. All right, so now because of the beautiful abstraction layers of, in particular, Spring Cloud Streams, I basically do not need to make any coding changes in order to start using a superstream. Basically, what I need to do is put in my properties. So in my properties, I'll go ahead and maximize this. So again, just like before, I'm specifying my bean, I'm specifying an alias for the bindings, and I have the group is the same, but the destination is changed. And I'm not just telling Rabbit I'm using a stream, I'm also saying I'm using a super stream, and I have 2 instances of my app. So when I restart this application, this instance of the application, and I'll restart the other instance of the application too. So go ahead and restart them. So this is going to, again, take those, the properties from the application, application.properties. If I head over to Rabbit, this created the stream, right? So again, I said I had 2 instances of my app. It created 2 streams. If I look at, now remember, the super streams is a combination, I didn't mention this, it's a combination of an exchange and the streams. So I do also have an exchange, and the exchange is basically, this is sort of the internal details of how it's going to route for the same routing key to a particular stream. So if I go back, I don't have to the streams, for these two streams, I don't have any messages. So let's go ahead and let's populate some messages. So I'll go to my publisher, config, and I'll get rid of this code. And I have a live template for publishing to the superstream. All right, so in this case, I have a CSV file. The CSV file is located here. So the first value in the CSV file is the event details, the next one is the session, and the next one is the year. So I have a couple of entries for Rabbit, Postgres, and some other entries, right? So I'm saying, okay, read from the CSV file, iterate over each one of the lines. For each one of the lines, I'm basically providing a supplier. So this is going back to Spring Cloud Functions. So again, the supplier interface, it just has a get method, right? So again, whatever I want to return, Spring is going to send that and publish that to RabbitMQ for me. So in this case, I'm parsing the lines and I'm populating the value in the CSV file into the Spring.io event object and just returning that. Now, if I look at the import statements, if I clean up my imports, after I clean up my imports, there's no real reference, and I'll make this bigger, there's no reference to Rabbit in here, right? So again, just like the consumer application, I'll put the Rabbit details in my application properties. So I'll go to the the publisher properties. So here are the details here. So just like before, I'm specifying the name of my function, which matches my bean name. I have an alias for my bindings. Now, the group and the destination, they have to match, right? So if I move this over to this side, and if I go back to the application properties for the consumer, again, so this destination will match this destination, right? So I'm publishing to the same, to where the consumer is listening. So now that I have all of this, I can basically now send those messages, and I'll start my publisher. So it's going to read through the CSV file, and by default, the Spring Framework is going to call the get method of my publisher based on a schedule. So the default schedule is calling the get method every second, right? So every second it's going to be sending those messages to the stream. So if I look at this instance of the application, again, this instance of the application looks like everything. In this case, what I didn't explain is that one important detail about this particular application properties is it's also specifying the prefix, the how many partitions we have, and this is what I'm using for the routing key, right? So the session is basically used as the routing key. So every message that has the same session is going to be routed to the same stream. That is why every message that has the word rabbit is sent to this instance of the application. But let's look at the other instance of the application. Looks like this one has everything that has Postgres and Gemfire, right? So again, that's how you maintain the ordering, and you can scale by partitioning these messages over different streams. Okay, great. So that's pretty much how you use superstreams. So now let's talk about filtering. So with filtering, now suppose you have all of these messages in your streams. Maybe you have millions of messages. Maybe they're broken over or they partitioned or sharded across different streams. Now, but applications, they're interested in specific messages, right? So suppose I have one instance of my application, and maybe it's sending it to a user, right? So in this case, this user, it's not really a person, it's a bunny. This bunny name is Zen. Zen is an honorary member of the RabbitMQ team. The owner of Zen is one of the engineers of Rabbit named Diana. She gave me permission. She gave me this picture. Now, Zen, when I send a message to Zen, Zen is not interested in Gemfire and Postgres and all this other stuff. It's only interested in Rabbit, right? So I should only send messages that have related to the Rabbit session to Zen. But another one of my colleagues at Tanzu, Arul may be interested in information or events about Postgres or Dataflow. And Cora, who is part of this Spring team, she might be interested in Gemfire and Spring Monolith. And Vlad is actually sitting in the audience right here. He's another one of my awesome colleagues. He's also in Spain, so you should connect with him after the session. Vlad is advanced, and he might be interested in advanced topics like Valkey or Kafka, right? So again, how do I get these applications or these users just the messages that they need? And the answer to that is RabbitMQ Streams, right? So RabbitMQ Streams, RabbitMQ SQL filtering was introduced in Rabbit version 4.2, right? And what it allows you to do is you can specify, when you register your interest, you can specify a SQL filter, right? So every message that matches a particular SQL filter is going to be sent to your application. And this is a broker-side filtering. So for example, other technologies, when you're specifying maybe a SQL operation, it will create multiple copies of the messages that match your particular criteria. In the case of Rabbit, Rabbit is basically doing all of the filtering server side for you. So it's optimized in terms of the storage. It's not creating multiple copies of the messages. It is also optimized in terms of the network, because it's only sending you the messages that you're interested in, right? So let me show you this in an example. So in this case, I can do a SQL filter against an individual stream or multiple streams, right? So again, I'm going to do this. This is an example of the SQL filter. It's basically the where clause of a SQL statement. So let's look at the code. All right, so I'll start out with my publisher application, and pretty much, my consumer application. So pretty much my code is going to remain the same, but what I'll do is I'm going to change my application properties. Just trying to find my alias. There you go. All right. So in this case, I'm creating a new destination. This is going to create a new streams for me. I'm still using a super stream, and I still have my instance count of 2. So I'll go ahead and we'll restart this application, and we have these new application properties. Again, I just wanted to do this so I have a fresh stream, an empty stream, so I can start showing you the SQL, how to use the SQL filtering. So if I go back to the dashboard into RabbitMQ, again, I see I have these new streams, and everything's empty for these particular streams. So I'm going to publish some messages to that stream. And in this case, I'm going to keep everything the same. I'm still reading from the CSV file, still iterating to it. But in order to implement the filtering, I need to add metadata about the applications. So in order to add the metadata, what I need is, I'm going to wrap this and a message. So this is a Spring message, right? The Spring message is going to allow me to add additional headers. So the header that I'm adding is the session in the year. So everything I add as a header is a candidate to be used in the where clause of my SQL filter. So again, I'm using the session in the year. But I also need to make sure that I change my application properties so that I'm pointing for the publisher that I'm sending to the right stream. All right, so now I'm using the stream that has the word filtering in it. So when I go ahead and restart this application, so just like before, it is reading messages from the stream. Now this one is a little faster because I set the poll rate, so they're sent basically every 20 milliseconds. So if I look at my applications, again, this instance of the application, this one got messages about Postgres and Gemfire. And just like before, this one got messages about RabbitMQ, Rabbit, so on and so forth, right? So again, they were partitioned. But now I want to introduce my SQL filter, right? So in introduce my SQL filter, I'm going to go back to my consumer application, and I'm going to change this code. So in this case, I'm not going to use the interface. I'm going to start using the lower level details. All right. So I have my live template. So in this case, I have these various SQL statements, right? So this is, again, this is what Zen, the bunny, is interested in, right? With information related to Rabbit in this year. If I go back to the RabbitMQ console, you'll see that, again, I have these various messages that have been partitioned based on the sessions. I'm going to query against both of those streams, right? So for this stream and for this stream, I have something called an environment object, right? So the environment object is almost like a connection pool. So, and in that environment object, I have a connection, and I'm setting up this consumer. I'll have 2 consumers over these 2 streams, and I'll pass in the SQL filter, and then when I get a message that matches that SQL filter, this is what I'm doing to it. I'm basically just logging it out to the screen. What I also want to do is I want to get rid of the application properties because, again, I'm using the low-level APIs in this case, and I don't want Spring to get confused. And let's go ahead and restart this app. And I'm actually going to stop. I'm only going to have one instance of this app, so I'm going to stop one of the apps, and we'll restart this one. So remember, the stream has data about Rabbit, it has Postgres, it has lots of other messages in here. But again, this particular app, it only gets the messages that match my SQL filter, right? So see, got ones about Rabbit. This is all about Rabbit. If I wanted to change to maybe get data about the other, or get the messages for the other conditions, I'll just use one, for example. It's just as easy as changing this, my SQL filter, restarting my app, and again, just as easy as I can query data in a table, now I can query these messages in a stream, right? And this is a real-time query, meaning that if I have new messages, so I'll just publish some new messages. So I have this other, I have another CSV file. And this other CSV file basically just has some more events. So I'm just going to restart this. So it's sending more and more events. And those new events are basically picked up in real time from my SQL filtering. So again, you can use it as sort of like a database, also as a real-time querying engine, or using streams. All right, great. Let's go back to the slides. So I always feel like no talk is complete without some mentioning artificial intelligence or AI in some way, shape, or form. So I had to do it, right? So in this case, what I'm going to do is I'm using Spring AI. How many of you are familiar and have played around with Spring AI? All right. So if you're not familiar with it, you haven't played around with it, it's basically an abstraction layer to be able to talk to a model, right? So I have, I'm not going into details about it, but I have a model running on my machine. I have something called Olama, which provides an interface for my Spring application to ask my model a question. And the model is going to ask my app is going to ask the model a question based on the data related to the Rabbit session. What does it think about this talk, right? So it's giving me a survey. It's going to think, was it good? Was it bad? Was it okay? And it's going to try to match all of the records that are in this in the stream, and again return the results. So let's look at the code. So I'll go back to my consumer application, and I'll get rid of this code, and I have a template, and I'll walk through the code in this template. Again, just like before, we're querying. Well, first of all, I have a prompt. So this is what I'm going to ask the model, right? Basically, what is its opinion about today's talk? But it's going to use the data from the streams. It's going to match records in this SQL filter. I have my environment object, I have my connections, I have my consumers. Now this is new, so this is a chat model. So this is Spring AI. This is going to allow me to interact with a model running on my machine. And when I get data, it's going to call this handler, and I'm going to call this subscriber. And what is the subscriber doing? The subscriber is basically adding these events into a list. And once it gets, and I'll start this while I continue to work through it. And once it gets 8 messages in the list, it's going to ask the model, what does it think about this talk? And it's going to return the results into this record. So this record is a survey object. It has an opinion. It has a rating of whether it was good, bad, or okay. So let's look at the output. So this is the verdict. So this model thought that this talk was neutral engagement, and they thought it was okay. So I don't know if you agree with the model, but that's pretty much all I had to cover today. So again, I hope that if you are able to connect with me, the best way to connect with me is on LinkedIn, and also check out my website where I'm publishing these examples and lots of other information about Rabbit. But we do have time for some questions. So if you have any questions, I'm here. Yes, sir.
Yes. So my question is, in general, when you're using the streams, does the producer need to be aware of the fact that they're sending something to a stream, or is it just really like an exchange and Rabbit manages the routing?
Yes. Great question. You do not have to. So remember, I started out by using the Rabbit Streams template. So in the name of the template, that's directly to a stream. But later on, I showed you the supplier. The supplier was talking to a stream, but again, the Spring Framework is hiding the fact that it was actually talking to a stream. So you can get abstract as you want, and that's really the beauty of a stream. But there's sometimes you need to get more lower level, right? Especially maybe some advanced features of streams that may not be supported in Spring, so you can, but you don't need to.
Yeah, so just checking, but that means that existing producers that may already live in connected to a Rabbit cluster could be made to also publish to a stream.
Yes, and that is an excellent point, because what I didn't mention is streams is just a type. In applications today, whether they're using the legacy protocols like AMQP, any version of AMQP, there's also MQTT, there's all of these different protocols that Rabbit supports. For all of these protocols, you could send data to a stream, and you'll get an improvement in performance, but you'll also get the replay capabilities. Yeah. So yes, you can take those existing apps with minor changes and just start using streams. Great question. Thank you for the question. Any other questions? All right, if there's no other questions, again, thank you for your time, and have a great rest of your day.